Okay, so we're continuing from where we ended last week. Last week we looked at forces. We said that the forces that will tends to change the state of the body. So from rest to motion or motion to rest. We looked at Newton's first law, second law, and the third law, and its application in the at the hospital. Some of the application at the hospital. We looked at work done, force times distance. We looked at the mathematical formula for a force. So today we're going to continue with a machine, and we are used to machines everywhere in our line of work. There are machines we used in our line of works. What is a machine? A machine is any device that makes work easier. A machine is any device that makes work easier. Now, for a simple machine, we have 6 simple machines. We have a lever, we have an inclined plane, we have wheel and axle, we have a pulley, we have a screw, we have a wedge. These are examples of 6 simple machines. Now, especially with the machine, definitely you are going to apply a force at one side, which is called the effort, to overcome a load at the other side. Okay, so let's say you are dressing the wound of a patient. You use a pair of forceps to pick the cotton and all those things. That pair of forceps is what? A simple machine. It's a lever that is helping you to do the work. Okay, the staircase is a simple machine. It's an inclined plane. Okay, so you want to use the wheelchair. There is an inclined plane for you to easily change the vertical height. Okay, it's a simple machine. Okay, so we're going to zoom to the lever. We want to take the lever first. Okay, what is a lever? A lever is a rigid bar with a fixed point of turning. A rigid bar with a fixed point of turning. Now, the fixed point of turning can also be called the fulcrum. Okay, the fulcrum or the pivot. The fulcrum or the pivot. Okay, the fulcrum or the pivot. And where you apply the force is the effort. So the effort, the force you apply to overcome a load. Okay, and what you want to overcome becomes your load. Okay, becomes your load. So in a lever, there are 3 basic terms: load, effort, and pivot. Load, effort, and pivot. So you can see that in the diagram, we have the load, okay, we have the effort, and we have the fulcrum or the pivot. So this is where the turning will occur. This is where the turning will occur. So let's go to classes of levers. What are some of the classes of levers? We have 3 classes of levers. We have the first class lever, the second class lever, and the third class lever. So the first class lever, the second class lever, and the third class lever. And all this classification of levers, they are defined based on the position of the pivot, the effort, and the load. Okay, so for the first class lever, the pivot is between the effort and the load. The pivot is between the effort and the load. And for the second class lever, the load is between the pivot and the effort. And the third class lever, the effort is between the pivot and the load. So the definitions of the classes of lever depends on the position of the pivot, the effort, and the load. Now, so the first class lever, you have the load, okay, you have the fulcrum, you have the effort or the force you're applying. So when you take a pair of scissors, it's a classic example of a first class lever. So this is the middle point, okay, is the fulcrum or the pivot. And a scissors, where you apply the force, is the effort. And if you are cutting something, that becomes your load. A pair of plier, okay, a pair of plier is also an example of the first class lever. A claw hammer is an example of the first class lever. So we know that for a first class lever, the pivot is between the effort and the load. The pivot, the fulcrum, the point of turning is between the effort and the load. Okay, so we move on to the second class levers. What's the second class lever? A lever having their load in between the effort and the pivot are second class lever. Okay, having the load between the effort and the pivot is a second class lever. So if you have a trolley, the one they used to carry the oxygen cylinder, the oxygen cylinder is the load, okay, and the one pushing the trolley will have to apply a certain effort, okay, and the ties is the pivot where the turning takes place. So it's a simple machine we use at the hospital. Now, wheelbarrow is also an example of the second class lever, where you put the load in the middle, then you push at the handle, then the ties, you turn it at the ties, okay. That is a second class lever. Knife, bottle openers, paper cutter, nutcrackers, these are examples of second class levers. So we move on to third class lever. What is a third class lever? Now for a third class lever, the effort will now be between the load and the pivot. The effort will now be between the load and the pivot. Example of a third class lever, you have a pair of sugar tank, you have a nail clipper, you have a cutlass, you have the hole, you have fishing rod. These are classic example of the third class lever. Like the pair of sugar tank, when you go to a party and they are serving chicken, okay, there's this pair of sugar tanks where you used to pick the fish or chicken. You see that you apply the force, the effort is at the middle, and the load is the chicken you are going to pick, and the pivot is at the end of the pair of sugar tank. Okay, so that is an example of a third class lever. And these are all simple machines. They are all simple machines, and they are to help us to make work easier. Okay, work easier. Now we move on to mechanical advantage. These are some terminologies and definitions when it comes to machines. You have to understand mechanical advantage. What is mechanical advantage? Mechanical advantage is the ratio of the load to the applied effort of a given machine. The ratio of the load to the applied effort of a given machine. So mechanical advantage has no unit because force over force, so the unit will cancel out and it will be dimensionless. Okay, dimensionless. Now mechanical advantage mathematically is load over the effort, the load over the effort. So let's take an example. A force of 50 Newton was used to raise a load of 200 Newton. Calculate the mechanical advantage of the machine. So we have to calculate the mechanical advantage of the machine. So solution, We know that our load is 200 Newton from the question, our effort is 50 Newton, and our formula for mechanical advantage is load over the effort. Therefore, 200 over 50 will give us 4. So the mechanical advantage is 4 units. Now you have an assignment, okay? You submit it on the page, okay? You submit it on the page, the portal, the learning platform. A machine with a mechanical advantage of 3 raises a load of 300 Newton. Find the effort applied on the load. Find the effort applied on the load. That is the first question. And the second question is the effort arm of a first class lever is 4 meters and the load arm is 2 meters. Calculate the mechanical advantage of the lever. So I will upload this exercise as a quiz on the e-learning platform. Then you do it and you submit it. We go to the second terminology, which is velocity ratio. And it's very important that you understand velocity ratio. What is velocity ratio? Velocity ratio is the distance moved by effort to the distance moved by load at the same time of a given machine. So the distance moved by effort to the distance moved by load at the same time of a given machine. And mathematically, velocity ratio is equal to distance moved by effort over distance moved by load. Distance moved by effort over distance moved by load. That will give you the velocity ratio. Distance moved by effort over distance moved by load. Now, similarly to the mechanical advantage, velocity ratio has no unit. It has no unit. Example number 1. In lifting a load of 200 grams through a distance of 8 meters, the effort moved through a distance of 10 meters. Calculate the velocity ratio of the machine. So we have to calculate the velocity ratio of this machine. Now the solution, we know that velocity ratio is distance moved by effort over distance moved by load. What is the distance moved by effort? In lifting a load of 200 kg through a distance, so you are lifting the load of 200 kilograms through a distance. So that is the effort distance, okay? You are lifting it through a distance, so the effort distance. The effort moved through a distance of 10 meters. So the effort distance is 10 meters and the load distance is 8 meters. In lifting a load of 200, so in lifting a load, the load is being moved through a distance of 8 meters and the effort is moved through a distance of 10 meters. So to calculate the velocity ratio, we have distance moved by effort over distance moved by load, which is 10 over 8. That will give us 1.25 as the velocity ratio. Now we move on to another terminology in machine, which is efficiency. What is the efficiency of a machine? The efficiency of a machine is the ratio of the useful work done by the machine to the total work output in the machine expressed as a percentage. So efficiency is equal to work output over work input times 100. Okay, you are inputting a certain amount of effort. Okay, now the machine is able to give you a certain output of work. So you are finding how efficient the machine is. And there is no machine on earth which is 100% efficient. No. All the machines you see is not 100% efficient. It cannot convert all the energy input into useful work. It's not possible. So definitely part of the energy is used to overcome friction, part of the energy is used to produce heat. So a machine cannot be 100% efficient. Like we, the human body, we are also a machine. Okay, in digestion, we don't 100% digest all the food we eat. Okay, part comes as waste. That's why we visit the washroom. Okay, because those are wastage. So even the human body, God in his wisdom designed that we are not 100% efficient. Otherwise, when we eat a certain calorie of food, we should get exact calorie of energy, but part of it is released as waste. So it's not all the food we eat that turns into nutrient, and part definitely come out as waste. It means that the energy input, the amount of energy we're expecting from the food, we should consider part coming as what? As waste. So a machine is not 100% efficient. Okay, so the efficiency is work output over work input times 100. And if we are able to have a machine that is 100% efficient, then we are solving a certain energy problem. Because at the end of the day, if I buy energy of, let's say, 20 joules, I'm able to use that 20 joules to give me another equivalent work of 20 joules. It means that there's no wastage. Okay, when you go and buy fuel, most part of all the fuel you go and buy end up as heat. Just a small percentage is used to move the car. Okay, so that is efficiency, and it's a percentage. Okay, work output over work input times what? 100. You can also define it as the ratio of the mechanical advantage to the velocity ratio expressed as a percentage. Mechanical advantage over velocity ratio times 100. Reason why machines are not 100% efficient, the efficiency is always less than 1 or less than 100%. Number one, some of the energy input is converted into other forms of energy like heat. Okay, yes, it's converted into other form like heat. Some is used to overcome friction. You use part of the energy to overcome friction. 3, some is used to overcome gravitational force. Part of the energy is used to overcome gravitational force. And 4, some is used to overcome inertia, the inertia of the body. Okay, yes, the inertia has to do with the first law, Newton's first law. Everybody has a certain inertia. So when you start the car, the power of the car should be able to overcome the inertia of the car for it to move. Okay, so the inertia of the car should be able to what? Overcome. Okay, so that is what? Inertia. So use part of the energy to overcome inertia. And these are some of the reasons why a machine is not 100% efficient. Example number 1. The energy input of a machine is 7.5 joules and the output energy is 5.0 joules. Calculate the efficiency of the machine. So you have to calculate the efficiency of the machine. And know that we said that the efficiency of a machine is what? Work output over work input times 100. So it's for us to identify which one is our energy input, which one is our energy output. So from the question, our data, we have the energy input of a machine is 7.5 joules and the output is 5.0 joules. So you are inputting a certain energy of 7.5 joules, but you are getting an output which is less than 7.5 joules. So we have to calculate the efficient, how efficient the machine is, how effective, efficient the machine is in terms of energy conservation. Formula is work output over work input times 100. So now our energy output is 5.0 joules. Our energy input is 7.5 joules times 100. So we have 66.7% So the efficiency is 66.7%. It means that almost 33.3, okay, 34.3 of the energy goes out as waste. Yes, goes out as waste. So you have an assignment. The mechanical advantage of a machine is 5 and its velocity ratio is 8. What is the efficiency of the machine? Okay, so this will bring us to the end of lesson 2. All right, so one of the things that will help you is to go over the video and the slide repeatedly. Okay, use me in the video. You can pause, you can forward it, you can rewind it. That is why we are doing the video. So make sure you go through not once, not twice, but as many times as time permits you. All right.